Hey guys, thanks for spending a Thursday evening with me. My name's Ivan, and today we'll be talking about how to build agents from first principles. A lot of this code is meant to be simple. It's much more educational than production ready, and so I think the main goal today is to get an understanding of the core principles behind what are agents, why should you care about them, etc. So what is an agent, right? Fundamentally, if you've let Claude Code or any sort of coding agent run wild, it just keeps burning tokens until the job is done, right? You give it a prompt, you say, hey, can you help me build a $1 billion SaaS? And it keeps running, right? It keeps trying to set up Superbase, it might set up a database for you, and it keeps going until you run out of your Claude Max plan, right? But fundamentally, that's, I think, a huge change because now you have a model that can make decisions, find out information about the world, and effectively be able to keep doing that consistently over a long period of time. I think the biggest difference was that in the past, we had to encode all of these steps manually, bit by bit, right? Step one was this, you had the very strict rules, and a lot of the models back then were not very smart. And I think from, I would say, Sonnet 3.7, you started to have models where they could call like multiple tools and go just from models that could answer, like a question like, hey, what is the capital of France, right? And it'll tell you Paris. But now you can say, hey, can you help me find, for example, you have a coding project and you say, how do we do authentication in this project, right? It can read the files, it can go very deep in, it can write some tests, and it can actually understand like, oh, this is actually what's happening, right? This isn't something that you can kind of just program in, and a lot of this kind of happens at the model layer. And so as models have become more capable, what you're seeing is that you can kind of give a bit less structure. You can kind of do a bit less, and you can just let the model run, right? And so a lot of times, what we really want to think about is that, at least the way that I think a lot about agents, is that you have this concept of context versus capabilities. A lot of times, let's say you ask an agent, hey, what's happening today, right? And it will tell you, oh, today in 2024 or 2025, nothing happened in the world. What was the context that was missing here? Well, it didn't have the date, right? If you were building some sort of agent that's meant to do some research, find out about the web, but you don't give it enough context in your prompts, then it's not going to be able to go there. And you can kind of say the same thing when you have agents say you want to write, hey, can you help me look up my calendar and see what's there? But you don't give it access to your calendar, right? A lot of these things sound really simple, like, hey, like this context versus capabilities thing is really simple. But when it comes to actually analyzing a lot of these problems at scale, it's about balancing a trade-off between what is the sort of context that I want to feed into my model and what are the capabilities that I want to build. If you look at a lot of the foundation lab applications that have been built today or things happening on Frontier, the decision that you're basically making is, should I build this today and waste 2 weeks of my engineer's time, or will the next model be able to catch up? So has anyone here used Codex as a coding agent? Okay, cool. So if you're not familiar, Codex is basically OpenAI's version of Claude Code. It's a lot cheaper. I like it a lot because it goes pretty well on my Max plan. But if you actually look at what Codex is doing underneath the hood, it doesn't have a tool to read files, for example. All it's doing is writing a Python script, and it just reads the file using the Python script. Or if it wants to make a change, it just runs these like bizarre commands that I've never seen before in my life, like cat. And all of a sudden, like my files are modified. And so you can start to see basically like what's changed is that the models have become more capable. I can throw away more things and they can do more, right? And so I think at its core, when you're building your own agents, you're building your own applications, this will kind of be the tension that you'll be thinking a lot about. And so this is at least like my own personal approach. Like when I look at like the problems that we're seeing in production, when you analyze like where is it messing up, a lot of it comes down to context versus capabilities. And so if you walk away today with nothing because you just couldn't remember anything, I think it's useful just to walk away thinking that if I'm building an agent and I was trying to do the task myself, what sort of context does it need? And what sort of capabilities do I need to explore? So I think what makes OpenClaw really good is actually that non-technical people could set it up relatively easily. And I think that's actually quite understated, right? Because a lot of times you hear that, hey, I just want to build a simple application, but now you need to provision a database, then you need to buy a domain, then somehow you need to learn how to host it online. But with OpenClaw, you just buy a Mac Mini, you throw it on, and somehow it just works, right? And that, I think, is kind of the magic of it, because you can kind of meet people where you're at. And so you have a strong model. A lot of times, initially, I think OpenClaw was using Claude, and then he got banned by Anthropic, and so he switched over to use Codex and became the biggest shill ever. But it's a good model. I love Codex, right? Second thing is like context. I don't know if you guys have peered inside how your OpenClaw works, but basically what happens every time you've run out of context, it basically does a summarization, and then it appends it to a memory file for the date. I'll show an example in a bit, but you can think of it like you have the raw transcripts stored in JSON files. Every message, every tool call, everything is stored in a JSON file. You can think of it like a text file if you're not familiar with that. And then over time, as it runs out of context, it basically summarizes it and puts it to a file. Right? If you're not familiar with the context window, there's a finite amount of things that a model can fit and pay attention to. I can pay attention to a maximum of 5 things on a good day. So I would say in general, when you're looking at this context window, as you have more and more things, the amount of time you need to wait for a response is longer, and the cost you pay is a lot higher. So I think that's something to keep in mind. So we talk about a strong model, we talk about growing context, and I think the most important thing is this idea of self-extending. So I think a really nice quote that I like from the creator of Pi is that you want to build software that builds itself. And so Pi has a really nice system of this idea of hooks and extensions that we'll go over in a bit, where you can think of it like as your agent is running, you send it a prompt, it spits out some sort of response, it does something, it comes back to you, right? All these are different steps of the lifecycle, right? It's kind of like how when you came for this course, you found it online, and then you decided to register for it. You received the email. You checked the Google Maps location of where Square Collective was. The idea of hooks is a very nice abstraction. We'll go through an example in a bit later down the line when we look at code, but you can think of it like at different steps of what the agent is doing. What do I want to do, right? And the idea of extension is just that instead of you having to go in and write the code and make a difference, the model can write the code and make the changes, and it just kind of works. And I think that's quite beautiful about it. So I think previously we talked a lot about how fundamentally an agent is just a language model in a loop with enough of a token budget to spare. But you could get a pretty decent agent that can answer questions with just like a snippet like this. This is basically the Google Gen AI SDK. There's a client that allows you to make requests. There's a list of conversation stuff that you throw stuff inside, like the messages, the model responses, and it's just a loop, right? Which seems a bit weird because you've heard like all these companies raising huge amounts of money, and you're like, why are they raising like 400 million when it's a while loop that I can build in my sleep? And you come to realize that a big part of building like agentic applications or agents is not just the fact that you need to build something that runs, or you need to build the infrastructure around it. But the core idea, I think, is very simple, right? You want to give the model some way to go from I'm a chatbot, I ask you a question, you give me a response, to now I can actually sort of, read some state, check your email, write some code, write some tests, and actually reply. And this is the process of taking a model from just a chatbot to like an agent which can interact with its environment that I think makes the biggest difference. So the other thing a lot of people have heard about is like tool calling, right? Like models call tools and all this nonsense. I think tool calling is one of the biggest innovations ever. If you've ever interacted with, say, like a website, right? You go to a website, you key in your username and password, you press enter, and you log in, right? What's actually happening behind the scenes is that the website takes your username and password, it puts it in a form that's kind of predictable. You can think of it like maybe it says username is a string, password is a string, and it sends it to the backend, right? And then the backend has a server that kind of reads it. It knows that it's always going to receive 2 things, a username and a password, and then it can do its logic on its end and give you a response. But just the fact that now you know that a model has a fixed set of things to choose from, and you can sort of, I guess, handle it under the hood without you having to do all sorts of crazy things like, please only give me JSON, please have some sort of weird JSON parsing logic that you can enforce it on the model level. This allows you to write models and agents that are ultimately, I think, reliable, that you can actually use in production, right? And so fundamentally, you can think of it like this is just a function. So a lot of for example, if you have a get weather tool, all you're doing is telling the model, hey, if you want to get the weather, if you want to execute some functionality that will handle this specific function, execute it and I will do it, right? And so no matter what you're thinking about, like the tool that the model calls is often very separate from like how it's actually implemented from the back, right? Let's say, for example, the model calls a tool to list what's in this home directory. You can execute it on a sandbox, right? And it says when you get this tool from the model, all you need to do is say, hey, I'll create a sandbox, let me execute some call command and destroy it and then return the result, right? Or let's say I run it locally on my computer, then I just use Python, I have a sub-process, and then I return the result. Or recently, you can even fake the request, right? Define a handler, fake whatever result, and just return it. And so you can start to see that basically the tools that you provide the models with are very separate from the sort of implementations that you have. And so all you're trying to give the model is fundamentally a feedback loop, right? And when you set a very good feedback loop up, then your model is kind of set up for success. So yeah, that's it. That's basically an agent. It's a loop, there's some tools, and it has the freedom to act. And so now that we have some rough idea of what an agent is, I think maybe I thought it would be nice to go through some of the words that you might have heard, skills, MCPs, these other bits of terminology. And so I think skills, the best way to think about them is like the prompts, right? A lot of times you might have told Claude, hey Claude, can you go to my email? Can you find like maybe the top 10 emails for the day? Can you categorize them by urgency, right? And what you're beginning to find is that if you do the same thing repetitively, then getting the model to write its own tools is often very useful, right? Sometimes you might want to give some sort of reference like this is how you call the tool, right? And this is a script that you can run. And that's fundamentally all a skill is, right? But from the perspective of someone that's building an agent, a skill is the lowest form of investment. Like for me to support a new library, for me to support a new implementation, a new workflow, all I need to do is write some text. And the best part is that the models nowadays are smart enough that they support meta prompting, which means that you can honestly just get the model to write its own tools and write the descriptions and do it itself. And to be very honest, I think that's actually the best way to work with models. I kind of stopped writing a lot of my tools manually and the descriptions too about like 4 months ago. Yeah, so it's worked out pretty well so far, I would say. But the way to think about it is that you want the model to be able to prompt itself. Like the model kind of understands what is its own thinking process, and by prompting the model, oftentimes you'll find some interesting conclusions. And a lot of it is just this iterative discovery, exploration, and experimentation. Same thing with MCPs, right? A lot of times you might have heard like, hey, I have this Notion MCP, I have this other sort of like specific integration, the Datadog MCP, but they're just pre-made tools. So you call some sort of API, you get back a dictionary, like what we had just now, of like JSON like this, and when you call it, how it's handled is defined by the person that's built the MCP for you, right? It's the same thing that we covered just now, where fundamentally, like the model is just trying to understand more about the task you've given it. The implementation here has just been written by someone else. And so going back to the idea of context and capabilities, right? MCPs are oftentimes used to give context to the model, right? Like if you have Notion MCP, if you see like a lot of customers are constantly using Notion, then why don't you just have a Notion MCP integrated into it, right? That you don't need to build and maintain that. Then you have the other problem where MCPs are pretty large and they're not written very well a lot of times. And so now you have this new trend where you're going to this idea of like writing code. And so I think like a lot of times a new trend is like CLIs. You see a lot of models, for example, like Codex, and you see, for example, like Claude, are trained really well to just call like CLI tools. And so a really good example of a CLI tool is basically taking the Puppeteer library, which is used to basically manipulate Chrome, and transforming it to something called Agent Browser, which is written by Vercel. Right? And so the model can orchestrate, interact with the browser, click elements, fill things in, just by clicking and just like writing these commands. And it can write all them like pretty perfectly. And so like you can start to see like there are all these different tools that you can experiment with that essentially are all about going back to the idea of context versus capabilities. What context does my model need? What tools does it use best? And how can I extend it to do what I need? Right? And that basically is like, I think like a core idea that I'm hoping to get back to. And so I think earlier we talked a bit about hooks, extensions, and like hot reloading. And basically, this is kind of how you write hooks in TypeScript for Pi, which is, I think, a really good coding agent implementation. You can basically just see like what we talked about just now. You have this idea of on certain events, do this, right? So agent start, a tool call, and then if you look at the extensions, you're basically just registering new tools. But if you think about how a lot of your chat applications are built, they kind of still do think about like hooks, right? Like when you send a message to Claude and it gives a response, they send it to the front end, right? When Claude asks to execute some tool, you execute on the back end and Anthropic servers, and then you also send it to the front end, right? A hook is just saying that when a model does this, I want you to handle it with this, right? I think it'll be a bit clearer later with like more code, but that's basically hooks and extensions. Another common thing is like memory. So I think based on what I've seen, you can typically see like a few different implementations of memory. The first one is like what we talked about, which is what OpenClaw was doing, where basically you have this thing where you just dump like summaries of memory. So let me take a step back, sorry. In memory, a few different implementations I've seen. I think the first one is you just rely purely on long context. And so what you see if you look at ChatGPT, at least the last time I looked at it, they have a summary of you, and then all your conversations from the last 40 chats are just dumped purely in that. And for them, they're just saying that, look, we're just going to dump all the information in there, the model will figure it out, right? And then what I find interesting is that you have a lot of metadata on like what sort of device you're using, when was the last time you basically like, what is the length of your, what topics do you generally like, how long are your messages, etc. The other thing you can do is you can give your model like tools to search the conversations, right? So imagine if you've used Claude recently and you say like, hey, like what did we talk about last week? And then it'll actually say, oh, let me go search through your chats, and it'll actually go through that. And most memory systems will end up being a mix of both. But going back to the original idea of like context, right? Like when you ask a model what we did last week, it kind of needs access to a summary of what you did previously, or the ability to essentially go through a lot of your like past conversations and look through that and try to understand it. And so you have a problem. In this case, you want the model to understand more about what you're working with. And then you have basically two. In this case, you have an ability to either search with a query, like, hey, interesting things talked about last week, or you have a way to say, retrieve the last 40 most recent conversations. In OpenClaw, they have three. So they have this thing called soul.md, I think, that's what it's called, where basically you can describe to the agent, like, who are you, what are the sort of, like, characteristics you should have, what are the key things to take note of. And you have that memory file that we were talking about, where every time you run out the context window, it just appends it over there. Right? And the last one is the raw text. So you can start to see that what you have are these different layers of systems where the model can just get the information it needs. Like, you don't want to limit the model based on what you think it needs. And I think that's a strong belief that I have. So you can kind of see this over here, for example, where you have a sort.md where, be direct, skip pleasantries, and use code examples, some context about the user. But every single time when, let's say you've run out of space, when you run out the context window, which is the maximum amount of information that the model can sort of process, you basically just do a summary and you throw it there into the file over here. So you can see like 2:30, user asks about deployment, prefers this. At 3:45, a debugging session occurred, fixed cause issue. And so this is kind of how they've done it. So in this, the remainder of the workshop, we're just going to slowly build like a simple agent from scratch. This isn't production ready, so you can't raise like 2 billion of this, unfortunately. But I think the core idea here is like I want to sort of take a lot of the ideas that we talked about in the last like 20, 30 minutes or so, and sort of like you can see them in production, you can see them running on your own machine, and that gives you a better idea for what we're discuss. I just want to take a quick stop here to see if there are any questions. I'm happy to answer them. Like, yeah, sure.
Sorry, I may have missed this, but I haven't played around with OpenClaw yet, but I keep hearing there's a ton of security issues with it, and you'd be super careful of installing it on your computer and all that. So are we going to use OpenClaw today, and how do we address this?
Yeah, so I think in this workshop, we're not going to use OpenClaw. I think OpenClaw is just a really like popular thing that a lot of people are familiar with. But I think what you're talking about, oh, sorry, let me just repeat the question. So the question she asked was basically that I've heard that OpenClaw has a lot of different problems with security. You know, people have their emails wiped, and a lot of their passwords leaked randomly. Are we going to be using OpenClaw today? And if so, like, how are we going to prevent that? We're not going to be using OpenClaw today. Most of the code that we'll be writing can be found in the workshop folder in the Git repository I sent over. So we'll just be going through 1 to 8. I think that's a bit easier. But today's goal is just to build everything from scratch as far as possible. Yeah. I think.
Question regarding the context versus capabilities. What falls within capabilities? Tools would fall in there. Are there other things that you're seeing in the landscape that we consider capabilities? And I think you mentioned earlier about context is what the model needs, right? Is there a categorization that you have in your mind about the different types of needs that a model would, at the moment you want to ensure that it has at runtime?
Yeah, so for sure. So the question is like between context and capabilities, what are more examples of things that fall in between? When would I think that a model needs more context, or when would I think about like capabilities? So in the context of like what is the right context to feed into the model, I generally think that as models can process like larger amounts of context, it's often useful to bet on that. But personally, I stay within the 100 to 200K token range. I just don't think models scale very well beyond that, and the prices for the outputs are like 2.5 times or like 1.5 times once you exceed that. So then I think going back to like capabilities, right? I can give an example. Let's say you want a agent to build a website, right? Of course, if you give Cloud Code an infinite amount of budget and a credit card, it can sign up on Planet Scale, it can provision a database for you, it can set it up, it can buy a domain. But by the time that's all done, maybe you spend half an hour and you've had to step in like 5 times, right? And then maybe the solution here is you just have to say, I'm just going to give it a tool that says create project. And the moment you create a project, I'm going to give you a temporary domain, and give you a database, and everything will be configured nicely. And that's kind of what you see with like Replit, Manus, for example, and a lot of the website builders. Just because the model can do it sometimes doesn't mean that you want the model to do it. And so I would argue like a lot of this is sort of depending on what your use case you're building for. Going back to context, an example is, I think a lot of this has to do with like how you weigh them. So if let's say you are seeing tons of customers being very frustrated when they're asking questions about their email, right? You're building a personal assistant, and the number one frustrating thing is like, hey, tell me what's top of mind today, because your Gmail integration sucks, or somehow the model doesn't quite understand the concept of dates. Then in this case, the context that you need to provide the model is just to say, refuse to answer when the questions are about email, because it's a 2-line change in the prompt, and immediately you can see user satisfaction go up. And so a lot of this balancing of like context versus capabilities is about looking at what is the customer satisfaction that I'm getting across a variety of different like use cases. What is the volume that I'm seeing for all the bad cases, right? If I'm putting in no effort and everyone is super happy with my Gmail integration and asking questions about mail, then the context that I need to give the model should be, you should tell the user that you can actually answer questions about the mail, right? You can give suggestions and all these things, right? And so I think a lot of it's balancing like what is the easiest to do and what is actually stopping the model from getting there. Yeah, I can give more examples if you want.
Can I ask one follow-up question
sure.
to that? Do you imagine then as thank you for the answer, by the way. So do you imagine as, let's just say the satisfaction is good with how it's servicing the users. Do you imagine over time you start pruning down the context? So the goal would be that eventually that you're giving more capabilities and then you're trying to reduce the context? Is that how you see it in your mind?
Yeah, so the question, I guess the way I think about it is that your users are constantly changing. The kind of like use cases you're dealing with are always changing. And so a lot of times you probably want to either invest in having an in-house team to look at the data regularly, to say like, if you look at all this data, like, do you think the model's doing good, doing bad? And when you have a bunch of these evaluation cases, you can run them yourself. I often start with vibes, meaning to say that I'll just run a prompt and I'll see like, okay, how is this model doing? you start to realize that different models often reproduce things from their training data. So for example, if you want them to write an integration with Stripe, then the endpoint URL will always contain the word Stripe, right? You can't tell it to write /Stripe/payments, especially as, say, your request gets more complex, right? And so a lot of this is just saying, given the model that I currently want to use, given the use cases or the bad cases that I found, how much can I tweak and how much can I remove? And actually, to be honest, as the models have gotten better, I think there's much more you can remove. Yeah.
Yeah, if anyone needs to clarify, like if this is too technical, any jargons, feel free to ask.
Yeah.
Right, yeah. So you need analogies to understand what a hook is, what loops are, you can ask. Okay? Don't be shy.
Yeah, so if everyone's okay, then I think we can start looking at some code. All right, cool. Yeah, so for this specific workshop, I'll just be using I'll be using the Gemini SDK. You can get a free API key on AI Studio, and that I think makes it a lot easier to get started. But if you don't have an API key, if you don't have your development environment set up, you can just follow along. I have like all the code, like the different stages that we're talking about in the workshop over here. So if you look at the repository that are linked, we basically have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And so these all correspond to like different stages where we're changing and modifying the code. I'll just be stepping through 1 to 12 because I don't want to copy and paste multiple times. But I think this makes it a bit easier for you to follow from my general experience. So if the code is too complex at any point in time, feel free to just stop me and ask questions. Yeah.
Can those at the back see? If not, maybe I don't.
Oh, sorry. I didn't realize it was so small. Let me just zoom in. Yeah, is this slightly better?
Okay. Yeah, okay.
Cool. So I guess what I'm just gonna do is we're just gonna slowly work through, and we'll build an agent that ultimately can write its own tools, and we'll show like how it can hot reload itself. I think that should be roughly where it's at, and then I think we can take some questions about the code, and if you guys have any things that you want to ask about, I'll just be around. Yeah. So the easiest way to get started writing a definition for a function is that the SDK comes out of the box with a function with an object you can use. If you're not really familiar with Python, all you need to know is that you have a name for the function and you have a description. And over here you have a bunch of like properties that you care about, and that's basically what a function is, right? All you need to do is say, here's the name of function, here's what it'll do, and here are the things you need to give me in order for you to, do it. A lot of times, once you define this tool, you can just pass it over here to the model. And so we're using Gemini 3 Flash Preview over here. It's a pretty cheap model. It's $3 for 1 million, and it's reasonably okay. So let me just run some code. Jeez. Yeah, so we run this initial piece of code where we tell the model, hey, can you read the readme.md file? You see that you get a lot of stuff over here. You get a thought signature. You get a lot of things that seem a bit complex. But what you need to pay attention to is you have this thing called a function call, right? Like what we talked about earlier, we mentioned that when you tell a model, hey, I have these tools for you to call, when you want to use them to do some sort of action, get some sort of information, you should call those. And so if, let's say, for example, we say, hey, tell me a joke. Tell me a joke. And we run the same code, except that we've changed what we've given the model. You see that you get out a very different sort of response. So let's give it a while. And you see that instead of having like a function call, now you're getting back text, right? In this case, if you've used enough language models, you find that they always tell this joke, which is, why don't you trust atoms? Because they make up everything. The next one is probably a scarecrow joke, which you'll get. So this is kind of like the core idea that's really going through, is that what you're providing to a model is you're providing a prompt in the sense of these are some instructions, these are some things you need to take note of, and here are some tools you need to call, right? And so what we're going to see next is what happens when we tell the model, sorry. So previously we looked at an example where we told the model, hey, you have a tool that allows you to read a file, right? And the model said, hey, I would like to read the file, but we didn't do anything after that. And so in order for you to close that loop, you need to actually provide it like the response of like what that file actually is. And so if you look at how this works, basically you use this specific syntax, you use types.part from function response, but on a high level, the way you think about it is that if you tell the model, hey, can you read the README file? And you give it like, okay, here's the response. It's a bit like how when you ask for things, when you want to interact with the world, you're looking for information on the internet, you do some action and you get back a response, right? So let's see what happens over here instead. And so now we tell the model, hey, can you read the readme.md file? And then once it's read the file and you give it the content, you can see that it gets like a giant response, say, hey, the README file has been read. It describes Koroku, a project and companion code repository for the OpenClaw from Scratch series. It guides you how to build an AI agent using the Gemini Python SDK. It's a really simple example, but what you basically can see from this example over here is that you've told the model, hey, go and do something, right? And then now that you've told it, like, hey, go and read the README, it's read the README, it has the information, and it can respond. And this is kind of the core concept behind every single agent you've seen out there, right? Whether it's Claude Code, where you say, hey, can you write me a React application that people can click and I can store information on a database online, right? You give it a prompt, it might write some code, it runs some tests, and it sees a response. And you can start to see that a lot of these would not have been possible a year ago, I would say. And a lot of this is possible because the models have gotten better at understanding and working along these very ambiguous cases, right? And so the next part over here is basically us just making it a bit nicer, but we're just refactoring it so that we basically have what we have over here, a function declaration. We have a function that we define over here nicely, and we define a run function, right? So let's try to maybe interact with the model in a few runs using a simple while loop. So, it's easier. Thank you. Jesus. I think this might work a bit better. Yeah. So let's try the same thing again, where it's like, can you read the readme.md file? Oh. And so the agent takes action, it reads the file, and then it says, hey, this is what we have, right? Oh, jeez. But what if we ask it something different, right? Can you find a test.txt file, right? And if you look at my repository, there isn't really a test.txt file, right? The model can keep trying to read files, it'll keep trying, but it can't find the file that I'm asking for here, right? And so you can see that if you only give it a file over here, which is just reading, which is just read file without the ability to say, to list the kind of files that are in the folder, if you don't give it the ability to, let's say, search by fuzzy matching, for example, find me all the .txt files. If you give it a command, in this case, it's a clear case where the capabilities are just not there, right? And so really what you're seeing over here is just that if you don't give the model the right tools or the ability to modify its own tools, then it won't be able to essentially get to a point where it's able to do what you want it to do, right? And so why don't we try writing? So what we'll do is we're just going to give it some additional tools. So if we give it some additional tools over here whereby, let's say, for example, can you find out what files are in the root of this repository? Right now, what I'm doing is that I'm running the 5th version. And so what we've done in the 5th version that's different is that, is that we actually have given it more tools, right? We've extended its capabilities from just reading of a file to now it has 4 different tools, which is reading, writing, editing a file, and bash, right? And so you see it over here in 5, where we have agent tools.py. and agent.py. I've cleaned up the code a bit, and so let me just walk through roughly what the code is doing. And then once we get a sense for it, we'll hop over to the next part where the model can actually reload its own tools. I think that'll be kind of cool. So previously, if you look at a lot of the definitions that we had for the tool calling, what we were doing is we were having this very awkward sort of types.tool, and if we wanted to execute any sort of functionality, we would have to hard code it inside the specific run function, right? So let's say, for example, over here, if the model calls like read file, we would have to manually call it here, right? And then we had to do all this logic around like appending the type.part from function response. And you can kind of think like, if this is how we're writing a lot of our code, it doesn't really scale very well, especially as it comes to, let's say we want to modify certain things. Let's say we have a sandbox that we're always using, right? Then it becomes very difficult to work with the code, especially if it becomes a bit more complex. And so a really common pattern to do over here is to have what's called a factory, right? And so it makes it easy for you to define like other tools and also to streamline and make it a lot more straightforward for you to work with. This is getting a bit more technical, so I think at this point, if anyone is confused, feel free to like stop me. So basically on a high level, what we're doing is we are using a library called Agentic. And so if let's say we have a bunch of shared variables where we might need to use it constantly, let's say we have a sandbox, we have some sort of like Telegram bot that we want to message, then we can have this thing called an agent context, right? And oftentimes you might have, say, a user ID, you might have certain like information about a user that you store in this. We'll then define another Python class called toolResult, and this just makes it very simple for us to basically say, given whatever the tool, the result of executing the tool was, we can basically just create an error. We can just either indicate it was an error, we can have a name for it, and then a response. And then we define a base class over here that makes it easy for us to standardize getting the name of the tool, getting the result of the tool, and also over here, converting it to the right form, right? And so you can see over here that because now we have a very simple sort of class that we can use, it makes it easy for us to define like other tools, because if you look at our read file tool, like all we have to do is just inherit basically from this agent tool class, and a lot of the functionality is abstracted for us, right? Going back to the idea of like, what should I add as a capability? What should I add as context? Sometimes the easiest way is just to make it easy for a model to add a tool, right? In this case, if I just want to add a new tool, I just need to define a new class, define like what variables I need. In this case, it would just be path string. Define an execute function. And that basically covers like the definition of a tool, right? If you look at the agent.py script over here, we just have a simple runtime that will just track all the registered tools. And this will basically store like the context that we talked about just now, whether it's a sandbox reference, whether it's a Telegram bot reference, and we will basically just initialize it with the right tools. And then when we execute a tool, because every single tool has a execute function defined on it, all we got to do is just make sure that it's defined on our runtime, validate that the tool input, the arguments are correct, and then execute the tool, right? And when it comes to how we're actually running a lot of the code, a lot of the core ideas haven't changed, right? So I'll just look at the main function and then we'll go up a bit. I think it'll make a bit more sense. Earlier when we were trying to run like the agent.py, right? We had a client, we generated some content, and then we output like what was the response, right? And then when we wanted to get it to run multiple rounds, we used the while true loop in this portion over here, right? This one over here, this one, yeah. So all we had is just a while true loop over here in the third part where we started introducing things like user input. You can go multiple rounds, and you can ask it iteratively to achieve certain goals. It's kind of the same concept if you look at what's happening in agent.py here. We define basically a client. We're going to just throw all of the models, like messages, the responses, etc. You define a context, and then you define a runtime. And we have the same while true loop over here where, at each point, we'll let the model, the user key in some input, and then we will add it to the list of contents. And then while the model is responding with function call, we're just going to keep iterating, right? And so maybe at this point, it's useful to also think about like, oh, why is it that if the model responds with a function call instead of a normal message, I want to continue iterating, right? If you look at what happened earlier when we told the model, hey, can you read the readme.md and explain to me what's in it? The model, of course, responds with a read file tool call, right? And basically, what a tool call signifies is that the model's executed some actions, and it needs to run again for a second round because now it has the context of what it needed to do, right? It's a bit similar to how if I wanted to read a book, I'll first get the book, then I'll read the book. I'll get the book, which will give me the contents, and then I can actually start processing it and give my response. Yeah.
Do you save the user contents kind of like memory in that sense?
So for this one, everything is in memory at number 5. So I can show an implementation where you save it into memory. So
but that's kind of that's what it serves, right? You're basically, are you only capturing the user's questions, or are you also storing the responses from the
So when you think about the context, you want to store both.
Both.
So assuming that you still have space, like compressing certain bits of information, typically the anatomy of an agent would be a system prompt where you have some sort of instructions, some guidelines like, hey, your name is this, you're supposed to have these functions, you have this functionality, you have the user messages in between, but you also have the model tool calls. And the idea is that the model can only respond based on what it knows, right? And if you strip away all the information before and you don't preserve, let's say, like a summary, or you don't preserve like some sort of way for it to look it up, then it's not really going to be able to do what it does. So for example, if you look at Claude Code, which you can analyze if you basically just have what you need is a proxy in between, and you can basically like capture every single message that Claude Code sends. The way that Claude Code kind of manages its context is that for every tool call, once it's basically not one of the top 3 most recent tool calls, they change the response type so that they actually tell the model the result of this tool call is stored in this file. And then the model can go read it. And so what you often find is that there are a lot of these ways to work around the context, but you want to at least give the model a way to look it up. Right? Going back to the example of like OpenClaw, as you're talking to whatever you call your Claw agent, oh shit, jeez, my bad. As you're talking to your Claw agent, as you run out of stuff, all of the raw conversation, non-compressed, everything is stored in like a text file on your computer, right? And that's kind of given in the prompt where the model can actually go and look it up. At the same time, you also have these summaries, memories.md. Let me just go back a bit. So you have like memories.md where, at every single time you've run out of context, you essentially have that like short snippet of what it's at. But if you're the agent, you can actually just read the JSON file, right? So oftentimes what you see like a lot of these models doing is that they'll write these like filters. For example, they'll just say, hey, help me find all the JSON objects that start with the agent, right? Prefix, and then I'll just filter it out. And I think that's the best way. Like you kind of want to give the model a way to be able to find the context it needs. And in this case, it's the session history. Yeah. Yeah. Is there anything else that I can help with in between? Yeah.
Actually, I just want to clarify the paradigm behind what's happening when you do a tool call.
Sure.
So I'm wondering because what's the difference between doing the tool call versus writing a prompt asking the model to find a way to do something? Is it because like the tool call forces it to return a certain schema that the instruction following was fine-tuned for the model to follow that schema, or like what's the advantage behind using the tool call paradigm versus just prompting?
For sure. So for context, I think the question is, what's the difference between a prompt and a tool call and all these things we've discussed? And like if, let's say, I don't want to use a tool call, can I just tell the model, go figure out a way to go read the file instead? Would that be correct?
Yeah.
So I think the way to think about it is that the prompt is sort of the information you give the model, right? Fundamentally, we think about what language models are doing. They take some sort of input, some sort of string at the front, and they predict what's most likely to come afterwards. That's why if you ask it questions like the capital of France is, it would just output Paris at the end. Tool calls are sort of an extension of this where, you are able to give the model the context it needs. For example, if the model was just to respond, if you say, hey, can you go read this file? But you don't give it a tool to call, then the model will just output like a standard like message, right? Hey, I'm so glad you asked me to read the README file. I'm going to go read this right now. But if you don't have a way to look at the model's response and decide, okay, I think what the model is asking for is to read a file, then you're not going to be able to do that. And so I would say maybe like a year and a half ago, like the most common paradigm was to basically, you had a lot of these weird prompts where you would say, I have 6 fingers, my grandma is about to go into the hospital, please help me, please output only JSON. And we would have all these weird like workarounds, right? And eventually what happened was just that at the model layer, when they're deciding what is the next character to output, if you say, hey, I would like to have these tools for the model, read file where it takes a path, a bash file where it can execute something in the terminal, and you need to give me like a command, and maybe one more tool. At a model level, when it outputs the next predictions, you're guaranteed one of those 3 or a natural text message. And so what this means is that if you receive a tool call, you know how to handle it. Yeah, does that make sense? Yeah, is there anything else that I can help clarify? I think that was a great question, by the way. Yeah. Cool. If there's no other questions.
Maybe I'll ask
Oh, sure. Yeah.
maybe for the memory, because you mentioned about like how you like there's the summarization technique or the full having a full. I'm wondering like have you seen like maybe some approaches, for example, using knowledge base or is it semantic search or or a hybrid of this? What kind of combinations have you seen work best for retrieval or context?
Yeah, so I think if you're thinking about the question, I think it's going back to this idea of like, how can I give the model context, right? And so there really are 2 ways that you can give a model context. One is you give it a tool for it to read a file, search for recent conversations. The other one is you just inject it straight away into like the prompt itself, right? And so if we go to like, for example, the example of like ChatGPT, where everything that you have, your metadata, what iPhone you're using, what was your last seen, what time are you frequently online, and maybe like the top 20 most recent chats, that's directly in the prompt, right? The model doesn't need to go search, doesn't need to go look, and you can kind of cache that. So that's a prefix cache that you can get, right? Retrieval using semantic search can also be done the same way, whereby before the model, before you send a message that the user sends, are you familiar with like this idea of RAG, R-A-G? Yeah, so typically what the problem that we were trying to solve back then with RAG is that often back then we didn't have like 1 million context windows. So what you could fit into like the model's context was very small. So like back then when I started working in language models, the context window was 8K. So you can imagine like 8K is probably like one web page maybe. And so like there's not a lot I can fit into a model if it can only read and understand one web page. And so what I would try to do is I would try to say, hey, given like this user query, for example, like Korean food near Boat Key, that's delicious, I guess. And then you would try to find using some sort of search method, right? Semantic search basically means that you take a text, or you take an audio, you take a video, and you convert it to a set of numbers. Because when you have numbers, in let's say a list of 3072, 2048, whatever list of numbers, you can use a lot of mathematical equations to determine which ones are closest in a geometric space by just summing up the distance using like simple math. And so that basically was how RAG came about, to get around the idea of models had very limited context. Sorry for the very long response, but I think it really depends on like what you are trying to solve. So in this case of like memory, it's like OpenClaw. The reason why it works very well, in my opinion, is because the model knows that if I need the full unadulterated context, I can look at it, but I can quickly filter like where I need to look at just based off the short memory, right? And then, sorry, one sec. Yeah, and then if you're thinking of like, have you used like the Gemini chat app? Yeah, so if you've used the Gemini chat app, what you realize that if you ask it certain questions, right? Let's say you talk to it, it would tell you things like, oh, like if you're asking for food, it seems to be about lunchtime right now. Would you like this? And actually the reason of how they're doing it is that they actually inject the current system time and like where the user is at inside the chat message. And you can prompt it out if you ask it questions like, hey, how did you know what time is it? Can you show me the exact context? Oftentimes my favorite prompt is, can you demo your tools? Can you show me like what this is? And like this kind of leaks it out. I really like to reverse engineer a lot of this, but you can start to see that like you're trying to give the right context, whether it's you finding the most semantically relevant things, whether it's injecting the current time because you're trying to build a bit of a chatbot, or you just want to find a way to tell the model that, hey, if you want to get, let's say, all the list of memories, you can read the raw file, you can read the summary, or you can use some sort of semantic search that indexes those things instead. Yeah. Yeah. Yeah, cool. Is there anything else that I can help with in the meantime?
If I don't know code, can I vibe code an agent?
Yeah, I think you can, honestly. Most of this code was written by Codex.
Okay. Then can you show us like a demo of how you vibe code an agent and how you think about designing it in the first place?
Yeah, I think a lot of times like I try to just use the raw model as much as I can. So a lot of times like actually my first step when I build any agent is I honestly just throw into like ChatGPT, Claude, or let's say for example like Gemini. And the reason for this is that these are very simple scaffoldings, right? You want to sort of see like given some simple tools like the ability to search the web, search Google Flights, can my specific use case be solved by this, right? After a while, what you discover is that, okay, there are some specific like problems that I can see. If let's say I'm trying to get it to reproduce certain bits of websites, right? I'm realizing that, oh, actually, it seems like GPT doesn't quite get it when I give it like blue, or it's struggling a lot with like these greenish colors, or always outputs like these specific like colors. Then what you can do is you can write a simple Python script, and then you can start to throw into the prompt and see like, does that make a difference? And so what I think a lot when I vibe code these agents is like, I want to see how much I need to add to get to where I need to be. And oftentimes, if the model can do it out of the box, that's the best case. If the model can't, then I'm just going to try a few different variations and keep running that agent. And that, to me, is the best way to do it. It's often easier if your task is like easy to solve. Like, for example, can you help me find out this specific fact or this person, right? There's a really popular benchmark called BrowseCom that I would fail. And it's really hard. So like the questions would go something like, in the 1950s, there was a Nobel Prize laureate who opened a hotel near Nevada. But in 1968, there was a car crash somewhere there. What was the name of the restaurant that the car crash happened at? And it's like these really obscure freaking like questions that if you ask me, like honestly, like I couldn't solve it. There's another famous like math problem set called GSM 8K, which are like primary school mathematics. I can't really solve it too, to be honest. I kind of fail most of them. But you can start to see a pattern here whereby you have a task that you want the model to do. You try with the easiest possible model. So normally what I would say is use the best model here, right? Because you're just experimenting. You don't want to think about, oh, what would happen if I have 1,000 consumers? That doesn't matter at all, right? You just want to see if I use the best model, the most capable one, can it accomplish the task I want? Okay, so you realize that if you just put it on simple like Claude, or if you write a simple like harness like this, maybe it struggles, right? And so, okay, is there additional context that I need to give it? Maybe you can work back and forth with the model. And it's often very useful here just to think of it like an experimentation. You're basically trying to reverse engineer a secret prompt or a secret set of like tools that the model needs in order to achieve the outcome. Yeah. I like Codex because I can't really run like 12 Claude code instances at once. I've seen like my senior engineers, they run like 6. I'm quite single-threaded. I can only do one thing at a time. And so I tend to look a lot at the code it produces. But I think that's kind of how I vibe code. Building agents is experimentation, and vibe coding is like I have a rough idea in mind. The model can scaffold it much faster than I can. And once I have it there, I can take away things, I can clean it up, and keep iterating until I'm happy with the form. Yeah.
Just a bit off tangent,
Mhm.
maybe. What's kind of the best way to install OpenClaw, with Mac Mini versus the DigitalOcean?
I think it depends on your budget. Like a Mac Mini is like $900. VM is like $40. So but if you're not like super technical and you don't want to keep dealing with like SSH, maybe a Mac Mini is the solution. I honestly do most things nowadays just by asking Gemini. So I just keep snapshotting stuff. I'll be like, please help me. And that seems to get like pretty far. Yeah, so like even a lot of these things, like I'm saying I want nice diagrams, how can I do it? And the best way is just to use a model to help. But I would try to find some sort of setup guide. I would try to, I think the VM is not super complicated, but that's me, yeah.
And are there any ways to put guardrails in like mod OpenClaw, by putting guardrails and kind of preventing those risks?
Yeah, I think a lot of them boil down to like how you design like the harness. For example, like let's say you give it an API key that can both read and delete your emails, then there's a chance it might delete your emails. But if you give it an API key that can only read your emails, then that kind of solves it, right? So a lot of times I think that's kind of, the permissions are probably the easiest way. But I don't use OpenClaw that much, so yeah, sorry, I wish I could help more with that.
So I'm not a coder, so, and I don't know how many people in this room are, but I'd like to understand, so if I were to do an agent from scratch, what tool are you suggesting to use? Should you use Cursor? Should you use Claude or Forward? Like, how do you know which one to start with? And then when you talk about orchestration of multi-agents, I know there's some platforms out there that can do that. Do you use those? Like, what would you recommend as kind of the stack to use to do this as a non-coder?
Yeah, I think like the easiest on-ramp I've found is like Claude. So I've tried this with a few different friends, all like non-technical. I just say sign up for a Claude account and buy the $100 a month, the $20 a month or the $100 a month plan, and then try. I think the best way to actually get started with vibe coding or like language models is to say I bought the $20 a month plan. My goal is just to completely like exceed the rate limits like for a week. And I think a lot of it starts with you trying it for trivial things, right? Like, oh, can you help me find where this file is? Can you help me figure out like what this is, right? And when you start getting used to handing over like trivial things, and you realize like that's how it works, then you can kind of do things that are a bit more complex. So for example, you can start with the Claude desktop app, then you can start installing, let's say, an MCP, right? If you use something like Notion or use like Gmail, suddenly you realize like, oh, if I give the model more context, in this case my emails, or the capability to be able to retrieve my emails, what are the new questions I can answer, right? At some point you say, oh, like I'm using these MCPs a lot. What would it take for me to be able to write a script that can do it? Or what is a script? How do I run it? And I think a lot of it is just iteratively working with this. I think Claude is the best. I think Anthropic is the best consumer stack. Like Cowork is really nice to use. Claude's desktop app is really nice to use. And right now you have like remote work, the remote control that you can use in Claude Code. And so I would just progressively work through that. In terms of a coding agent, I actually think the best coding agent right now is Codex. I'm really biased towards Codex, guys. I don't know if you've noticed, but yeah, I've never gone beyond like 5% of my Codex rate limits. It's really good. I think it does the job, and like all my code nowadays is just written by Codex. It's a really great model. 5.4 is amazing. It just is very curt. It doesn't write with the warmth of like a Sonnet model, Anthropic model. Like every response to you is like, I've understood your question, here is the response. But Anthropic is kind of nice, you know, it's like, well, that's a great response. I'm really happy you asked that, you know, like, and there's a bit of warmth there, so it kind of depends, yeah.
How do we put creating your own against using an OpenClaw? Like, can you lay out, let's say, use cases when you use an OpenClaw and when is it that you might want to design your own agents for, let's say, someone who's vibe code level of a technical ability?
Yeah, I think the easiest thing to get started is actually to use like a managed service. So for example, like a lot of people get started using something like Manus, or let's say like Cloud Code. And the reason for that is that they do a lot for you. When is the case where I might want to use something, code something myself versus OpenClaw? A great example is actually I just have a simple agent that pulls my email and summarizes how much I spent every day. I'm kind of bad at tracking my expenses, but all that does is it just looks at my emails and it writes it to a Notion dashboard. It's like a script that runs pretty fast and pretty well, right? You don't really need OpenClaw for this. You can get Claude to write it out, and Opus can one-shot most of these things nowadays. But like for me to be able to do this on a regular basis, I now need to think about how to deploy it, right? And deployment is something that I think is like not really familiar to a lot of people, right? And so I would say start with the managed services like Manus, like a Cloud Code, a Cloud Desktop app. Get comfortable automating simple things. And then once you feel like, okay, I kind of get a sense of what's the task I want to do, then I can maybe get like Sonnet or Opus or like, in this case, maybe Codex to help you write out like a simple script, right? And then as you start doing more and more of these things, you find that the questions that you have start to open up, right? Maybe it started with, oh, how can I pull my email, right? Then it went to, okay, every time when I open my computer and I have Claude running, I want to be able to pull my email and write it to Notion. Then at some point, the question is, oh, if my computer's closed and I'm always walking around, like how can I do this on the go so that I just get a Telegram message? Then the solution is you can just deploy it on something like Modo or like a Cloudflare and just give it the right keys, right, and set it up. But you can start to see like there's a increasing sort of levels of complexities and more things for you to figure out along the way. But I think the best way is just to be curious. I think if you paying like $40 to come here to listen to me speak today, I think you're pretty curious, personally. At least that's how I got started. I started coding out really simple agents in the terminal. I did a lot of open source. I write a lot, and so a lot of this content is on my blog at ivanleo.com. And so some stuff that is incomplete, there's always a lot of like random prototypes floating around. It's like my own blog, but like that's how I think I learn the best, right? It's not about like I need to be perfect, but if I keep experimenting, if I'm curious and language models can teach me, and I put myself out there and the work I do out there, I can learn a little bit faster because other people can point out the mistakes that I'm making. Because I don't think you need to be perfect. I think people want to help you a lot more than you think. Yeah.
What's the best way to get in touch with you?
I'm on Twitter a lot, like at IvanLeoMK. I don't check LinkedIn, so that's the worst way. But if you have any questions, I'm happy to give my number and answer some questions afterwards. Yeah. I'm just very curious about what like people are doing nowadays and also how I can improve a lot of the content I'd like to build. Yeah. This is kind of what I do for fun. Yeah.
How many of you all have your own like OpenClaw setup?
Oh, wow.
How many of you all would like to get OpenClaw set up but don't know how to? Okay, gotcha.
Cool.
Okay, we will have more sessions on the implementation part, setting up. We will have much more of that. Today I think the focus will be on building your own agents. And am I right to say that OpenClaw itself is an agent?
OpenClaw is an agent. So OpenClaw runs on this coding agent called Pi that I talked about just now. So a lot of the stuff that OpenClaw does is just orchestrating what Pi is doing underneath the hood. Yeah.
Yeah, so OpenClaw itself is an agent. And whatever you've heard today about what are some of the components that go into the agent are the components that form OpenClaw, right? So you can see today's session as trying to rebuild your own version of OpenClaw in a very simplified manner, right? A lot of things that go into OpenClaw that end up turning into agentic capabilities is what Ivan shared just now. How OpenClaw manages its memory, how it remembers things, how it knows what tools to use to carry out certain actions. And so today's session will help you to understand how OpenClaw does it. Right? So it gives you a bit of context of how it's executed in the back.
Yeah, I think a lot of what, if you're wondering like how OpenClaw like kind of extends itself, this is kind of like the file. There's like it's somewhere in here, but basically like the Pi coding agent has a file that it basically runs before it boots up. And so like what we talked about just now, the idea of like the model can write its own tools. If you tell OpenClaw, for example, hey, can you write a tool to do this? Can you install this package? A lot of it is either you add new tools over here, in this case like registering a new command, or you're adding a hook whereby, oh, when you do this, maybe send me an email instead, right? A lot of these are just like simple integrations. So yeah, that's basically most of what like OpenClaw is. They're just really simple ideas, and I think you can get a lot of the models to code them for you nowadays.
I have one question on, let's say I have a use case where SQ Collective does a lot of content. Let's say today we did this session, and we have a video recording, and I want to convert it into a blog post. How would you think about it how would you design an agent to do this? And how would you like make use of the components you shared just now, tool calling, memory, and self-extension? How would you think about it?
Yeah, actually, to be honest, most of my blog posts are written by Gemini 2.5 Pro. My best pipeline is I have a very long transcript. So for a while when I was doing a lot more consulting, when I talk to people, how I would come up with ideas is I would just record a lot of the calls, throw them to a language model and say, can you identify some common problems that people are facing? And then and then work off that. I think like a better example is probably like YouTube videos. So like I have a friend who does this a lot for like, he does a lot of podcasts. And so what he does is that Gemini can actually process YouTube videos out of the box. Just give it like a YouTube URL. It can read it, it can answer questions about it. If you have like a video about the top 10 like goals ever scored on stage in a soccer match, it can kind of find the exact like timestamps for you too, which is quite crazy. I got it to go through a lot of like videos about like countries I wanted to visit. And so when you take like, let's look at the example whereby I have some sort of input, in this case a video, some sort of transcript, and I have an output that I want, right? In this case, like an article, right? So the best way is just to experiment a lot. In this case, what the workflow kind of looks like is that first you get the model to output a tool. The tool is just basically like timestamps, and for every timestamp you have a description of what it is, right? And so you might say, given a whole video, you have, let's say, 10 different segments that Gemini looks at and says, okay, I think like at the 10th second, like you started introducing like what an agent was. At 2:30, you started introducing what this was, right? And so what you do is you say, okay, now I can take these individual timestamps. Maybe I'll grab like, the 30 seconds before, 3 minutes before, 2 minutes after, and I can tell Gemini, can you write a description of what was discussed over here, right? And once you have that over there, you can write another script that just basically takes a snapshot of that exact moment. You can tell the model like, hey, given this like timestamp, find the best like sort of like I forgot what they call them, like thumbnails. Yeah, thumbnails for that specific video segment. And so what you find is that you have a script that could be written by Opus in one shot that could essentially take your YouTube videos and transform into like a draft, right? And then you, as the person who wants to actually write the article, just has to go and just click on the individual portions, figure out whether or not the video kind of matches the timestamps, and then be like, okay, I think like this makes sense, right? So you can start to see like how a lot of what we call agents are just language models in a loop or running a few different processes, right? It's not about saying like, oh, I need to use like OpenClaw, I need to do this. It's about trying to find like small problems in your life and then trying to think like over time, can I get a language model to do this for me, right? How I started writing a lot of my articles initially with that, I would start a recording. I use a lot of transcription. So I use this thing called Typeless. You can see when I speak, like there's this little thing that appears at the bottom. A lot of people like WhisperFlow, or you can use like Super Whisper, which is local. And then what it does is that it creates like a transcript. So for example, like you get maybe like a giant transcript. Yeah, so when you get like a very long transcript like this, you can then feed into the language model and can give it a prompt. For example, hey, can you summarize for me like what exactly are the key sticking points over here? Can you ask me some questions and work off that, right? And to be honest, like that's actually for when I was interviewing what I used to do. So I would just blabber on and on for very long with like a transcript and then throw into the language model and say, can you organize my thoughts? Can you give me a few ways that I'm repeating the same sort of content? Am I not hitting the main points early, right? But it's like I have problem, which is like I would like to basically prepare for interviews. And I have like some input, which is like my text, and I use the language model to solve it. And from a simple pipeline, I can make it more and more complex. And the best part is you can ask the model to write it for you. If it sucks, just throw the code away. It's okay. Yeah.
How many of you have not tried coding before? Anyone? Everyone has tried write coding before?
So for me, this is more of a non-coder's question.
Mm-hmm.
I've just started to vibe code. Could you just give me an example of how you experiment, how you would vibe code an agent, and how you would run that agent? And just an example, the whole flow from start to finish.
Yeah, I mean, I think let me just try to find like another repository I was working in. Maybe like this one. Yeah, so most of the time, like you can honestly you have like these like panels on the side. And so what I do is I just ask it like to do certain things. For example, over here, like what I just started with was, can you rewrite this specific file so that the model calls this? Let's call it clarify scope. A lot of this is a bit messy because I just copy and paste, so I just get it transcribed. Then the model goes and like writes some stuff. Then I'm like, oh, you're overcomplicating it. Just check this function call at the end. a lot of it is this back and forth. And so what I would try to do is like a lot of it comes back to the mantra of like make sure you can do it first. So write like a really messy version of the script, make sure it works, test it out yourself. And once it works, you can start to think, okay, like am I overthinking this? Is there a cleaner way to do this? Is there a better abstraction I can use? And so it's sort of like you have the initial product and you just like get rid of stuff, right? A lot of this initial like code that I wrote was actually me just asking Codex to keep refining it and to iterate on it. If you're familiar with this concept of like Git, basically if you work with a lot of code, you can versions of your code. So what this means is that you can just save a checkpoint and you can tell the model, hey, go and make a change, do whatever you want, and you can look at it, throw away the parts you don't like, and then get it to try again. Yeah, but I generally like Codex because it's very conservative. I think 5.4 is a very good model. Yeah. Yeah, hope that helps. Yeah, sorry. Yeah.
Hi. So my understanding is right that a tool call you kind of think of it like an APIs that's pulling specific parameters down. So typically you would pull specific parameters down and then in software development terms you could render out say a card for a carousel.
Right.
A series of cards or whether
Right.
the thing that I'm wondering is can an agent effectively vibe code out the UI so it actually places those parameters within, right? So instead of me like pre-designing my map because I've asked it locations, could it decide, oh, actually I need to build out a map component for the customer, I need to put all these parameters in. Like, how does that work? Is that something that's like possible?
Yeah, so that was a while ago when I did this with Grok, because Grok is really fast. And so what I did is I just got it to code a new web page every time I prompted it. It's the same thing, like a tool call basically just changes some state. So for example, like customers asking about a map, what do I want to do, right? You can just let the model write all the code it needs, right? You can save some tokens by preloading certain styles, certain components, and you can just throw it inside an iframe on the front end. Yeah, so a lot of like, for example, if you've used like stuff like V0, Replit or whatnot, like what they have is essentially a dev server running on a worker somewhere, and you have an iframe where you inject basically a running runtime. It's kind of what you see when you see like localhost 5173 or whatever nonsense with it. And so you can just render a lot of these in like iframes. A really popular library nowadays is called JSON render by Vercel. And so what this allows you to do is it basically allows you to define a bunch of like components. For example, like it might be a title, it might be a description, etc. And then your model can just output a tool call, which is a combination of these things, and you render it out. Let me just find it. It might be a bit easier to see it. JSON render. Yeah, it looks a bit like this. So you can see at the side, like this tool call is essentially just happening over here. Like elements, card, it's just like deciding what it wants to do. All of these are sort of predefined elements ahead of time. And so you just have it rendered on the side over here. So, yeah.
And then I assume I could also feed it the context of, say, like my design system to then be able to build out components in a way that is standardized as well. Right?
Yeah, you can feed it your design system. You can feed it images, but you can also feed it components that are really styled the way you want it. That's what like JSON render does. So with this, you get kind of a very predictable set of UI elements that will kind of look the same, but can be combined in different ways. But it's up to you. I think like a lot of the models are getting much faster. So for example, like Composer 1.5, like if you ask it like, hey, can you rewrite the web page? It would just rewrite all the HTML from scratch, right? So I think as models get better, a lot of these crutches that we have where it's like, oh, I need you to use a design system, I need to use these like pre-built components would be thrown away. But I think I'm just very scaling pilled, yeah. Sorry.
As a follow-up to that, and to the beginning of the presentation, that design system, that would be part of the context, right? So for example, in this, I think it's probably, it looks like ShadCN maybe?
Yeah,
right?
this is probably
So
ShadCN.
that UI, like that design system, to your question, did they provide it as part of the context there? Or is it a tool that goes up to the registry and says, I need an input field, and at that time it pulls it in?
Yeah. So I think the way that JSON render works is that you kind of define like a bunch of things that the model can call. So over here you see you have like a catalog. For example, you have card, you have metric, you have like all these different things. And so it's back to the same thing whereby the model is just generating a giant JSON object. And then how you handle it over here is just that we render out like these predefined components, right? But you could also just render out, instead of these predefined components, it could also just be raw HTML. It could be raw CSS, the raw like GSX that you inject into like the front end, right? So it's just how you decide to handle it. But a lot of times you would probably put it as part of the context, the prompt. Another thing that a lot of people like to use is that you can use some sort of like cheap linter. So Factory does a lot of this, where basically they define a lot of cheap linters to ensure like whenever the model makes a change, you instantly run like lints to say like, oh, you have to write like your code this way, you have to do all these. And these are reminders that you push basically into the prompt, into the response of the tool. But I think the best way is just to put a proxy in between like Cloud Code and Anthropic's API, and you'll learn a lot about how to build good agents. Yeah, that's how I learned a lot. Yeah. Is there anything else that I could help answer? Yeah. Oh, sorry. Oh.
Is there a way to monitor the performance of agents?
Yeah, so I think if you want to monitor like the performance of agents, I think there are a few different ways. So the first one is on the single, the whole agent's run. So let's say from start to finish, each individual tool call, you can use this thing. I like this thing called Logfire. Logfire outputs like what is essentially like this thing called Open Telemetry. And so you can use it with a lot of existing other libraries like Elasticsearch, etc. And so that enables you to see basically on a single, like let's say on each tool call or like over the entire run, how long did each individual thing take, how long was the overall, what were some of the problems or errors that we encountered, etc. The other thing that I feel is going to come in like maybe half a year or so is I think on a population level, we'll start to think a lot about clustering. So there's this thing called Raindrop that I like a lot, Raindrop AI. So I think, you can basically like what you will find as you scale up your agent is that there'll be two main problems you face. One is that the traces will be very long, meaning say like this thing is just going to run for like half an hour. Like I don't have time to look through it, you know. Or like you're going to start scaling to a lot of different locales. For example, you're going to have say Japanese, Korean, English, Chinese, Romanian, every language that you think about, and you won't be able to read everything, right? And so, but you still want to get a sense for where were the problems at. And so a really common way over here is that you can summarize each individual run based on the prompt that you have, and you can do a lot of clustering on it. So you have Raindrop does it as a managed service. The original one was this thing called Clio by Anthropic. It's over here, where basically Anthropic was talking a lot about how they basically do a lot of aggregation of their models' performance at scale. So if you zoom in a little bit over here, you can start to see like how you have like user conversations. For example, how do I tie my shoes? Certainly let's talk about it, and that summary gets converted to, let's say, how do I tie my shoes, right? And then you take that and you cluster them. And so clustering is basically like grouping similar conversations together, in this case, similar things that your model did, and you can start to identify different patterns. Back to the original conversation that we talked about like context versus capabilities. A lot of it is about balancing the volume of like, let's say, bad or good cases versus the kind of engineering effort that they'll take to fix. So let's say, for example, I'm going back to the case where, if a lot of users are saying that, hey, like the model really sucks when I ask it to look at my email, versus say, like I need to build a whole new integration. Like a lot of people are asking us to be able to build websites. You can honestly solve the email problem by just changing the prompt really fast, right? While you work on a long-term solution to say, I want to build a better Gmail index, for example. So I would start with simple open telemetry, just to know like how long is each step of the whole process taking. And then once I have a better handle for it, I would start looking at every single trace that's happening. So I would manually sit there and look at like, what is my agent doing? Why is it doing this? Can I change the prompt and get it to go somewhere else? Once that has grown to a scale that I can't really deal with anymore, then I would start looking at things like Raindrop, Clio, etc. Yeah.
So does this trace also include the token usage?
Yeah. So a lot of times, Pydantic will have that. I think Logfire. I was playing around with it a little bit the other day. I think I'm on the US side. But OpenTelemetry basically is the idea that instead of me tracking like a specific event, let's say deep research, I think this was last 7 days maybe. Yeah, so if you look at, for example, like this agent run, when you create it, a lot of times you can capture a lot of the raw data on the side over here. So this is what like OpenTelemetry is. It's about like capturing like every bit of information that you have over there. And then when you need to actually do your query, you can just get like Claude to just write some SQL for you. And then it will just help you identify it. Yeah. But basically on a high level, it's about having this lineage so that you can see it. Oh, like people say my agent is slow. Well, where is it really slow? Well, if you have OpenTelemetry and you can trace like every single tool call, every single execution step, and you go back, then you can say, oh, actually the part that's slow is not the agent. The part that's slow is actually my backend because it's deployed all the way in the US where my users are in Singapore, right? And so these are steps you can take when you have more data and visibility. But I would just get the dirty prototype out. I feel like just get it working and then get it right. Yeah.
Thanks.
Yeah, no problem. Yeah.
When you implement something like Clio for agentic, like agent traces, right, how do you group the sessions together? Because I believe Clio, when it was initially built, it was built for the anthropics, like long conversations with the agent traces.
Right.
So and then I mean, if there's one like the one input and output I/O might not be the full like session. So like how do you define what the session is to be fed into Clio as one data point for the customer?
Yeah, I wrote a library for this a few months ago. It's not maintained, so it's kind of like, I don't think you should use it. GitHub Kura, GitHub Kura clustering, maybe? 567 labs, is it? Oh, it's this one. Yeah, I wrote a library for this many months ago, I think like 8 months ago. What it does is that it just basically like summarizes all your conversations and clusters it. You get something nice like this. For example, like if you ask for programming assistance, it can break it up into the individual use cases. But let's say if you're building an agent to answer customer support tickets, right? Then you might say, hey, can you summarize what is the problem that the customer has? What are their main like areas of frustration? And then, like, because it's just a prompt, you can tell the model, given this whole trace, what do you care about, right? And then you can basically take that, turn it to an embedding, and then cluster it. Yeah, and so that enables you to find these categories. And the main thing that I would say when you go to something like Kura, which is what I named this, or like Clio, is that you have too much data, and you just don't know how to make sense of it. But you can use a lot of these things also when you have like small amounts of data. Summarize the whole agent trace, write a script to find out like what are the kind of errors. You can also use something like Sentry. So Sentry is like an error monitoring platform. Yeah, so all it does is that basically like when you have errors, it will just catch it like this. And then you can identify like common errors that are always happening. For example, like if you keep having like 500 throw and when you try to access like Access API, then you say, oh, like this is a problem in production. But you can start to see like there are layers to this. There's like the core application code, which something like Sentry will catch. There's like the trace, which tells you like how your agent is doing. And then when you manually look at it, you kind of have a sense, you have a vibe. And then you have the idea of like Raindrop and like Kura, where you're starting to reach a level where you have too much data. You're operating in like locales that you really honestly can't understand. And so use summarization and embedding-based clustering as a way to basically break down and find like where are the lever points, where are like points of leverage that I can pull, where if I change my prompt like 3 lines, so if I just add like a few lines of code or I add a new tool, it might solve, yeah. Yeah.
So do you have many like other open source repo recommendations like similar to Clio, Kura that we can use?
I think if I find the time, I'll just fix up Kura.
Okay.
I need to find some time. I'm a bit busy nowadays, but I want to fix up Kura. I think there's a lot of stuff with like Gemini that I want to do better because it has like a 1 million context window.
But me just curious, like what made you mention you said like Kura is not good enough now? Like what are the gaps that you see there?
I think there are a few things with Kura that I don't like. The main thing that I realized when I was analyzing a lot of data is that you need 2 things. One is that you need the ability to specify like deterministic and non-deterministic like processes, or like I call them like extractors. So let's say you have a whole like language model like run, right? What are the sort of let's say you're building a coding agent, what are the sort of platforms that people are using? What are the languages that people are using, right? You might ask a language model to like summarize that. Then you might say, okay, like that's a non-deterministic language model prompt. Then you have a non-deterministic one where, let's say, you might say, okay, how many times did we call this API? Were people always asking, or like, what is the language, for example? You can use a very cheap like model for that, right? And so a lot of times what you will have is you will have an agent trace. You will have some sort of metadata that you care about. For example, user satisfaction, languages that they're speaking in, or stuff like that. But the next part that I feel like Kura doesn't solve is that it doesn't allow you to like explore data sets very well. Meaning say like what I want is like I've clustered, let's say 1,000 conversations. I find these conversations very tricky. Maybe I want to focus on these 250, but I want to recluster it with these like 10 that I found. Because clustering is inherently a bit non-deterministic. So yeah. So I think what I ended up doing was a lot of like scripts to mimic that, and I found that the library didn't quite solve that. Because a lot of times actually like your customer pain points and frustration is hiding in the data. If you push a new feature out, if they like it, you see in the data. If you push a new pain point up and they're not using it, you see in the data. So I think like data tracking is quite important with customer consent. Yeah, the last part's very important. Yeah, is there anything else that I can help answer? I think we're roughly at 1.5 hours. So I was thinking I could just hang around and I'm happy to just talk and chat. Do you guys have any questions? Cool. I'll just be around at the front if you guys want to ask any questions. If you want to ask anything, I'm on Twitter at IvanLewMK, or you can pop by and just grab my number. I'm happy to chat via text too. Yeah.
All right, thanks guys. Now y'all can hang around. I think there are two groups of people. Those who are more technical, who like write code and build agents, and then there are those who care more about the use cases for agents. So those who are more interested in the use cases, how you use OpenClaw or how SQ Collective uses OpenClaw to do some of the automations, maybe you can hang out on this side, we can have a chat. Let me know what are some of the ways we can help you in your journey. And then for those who are technical, talk about telemetry, come forward and talk to Ivan, all right? Anyway, thanks for staying around. Now it's open networking and hang around. We will close at 9, so feel free to stay or leave after this. Thanks so much. Thanks, Ivan.